Section 7.4, Mass percent, composition, and empirical formulas. Because of the atoms of the elements in a compound are combined in a definite proportion, they are also combined in a definite proportion by mass. Thus, when we know the mass of an element of a sample of a compound, we can calculate its mass percent composition, or mass percent, which is the mass of an element divided by the total mass of a compound and multiplied by 100%. Mass percent composition using molar mass. We can also calculate mass percent composition of a compound by using its molar mass. Then total mass of each element is divided by the molar mass of a compound and multiplied by 100%. The mass percent composition is the mass of each element divided by the molar mass of each of the compound times 100%. Empirical formulas. Up to now, the formulas you have seen have been molecular formulas, which are the actual formulas of compounds. If we write a formula that represents the lowest whole number ratio of atoms in a compound, it's called the simplest, or the empirical formula. For example, the compound benzene with the molecular formula C6H6 has the empirical formula CH. Some molecular formulas and their empirical formulas are shown in Table 7.3. Acetylene, C2H2, has an empirical formula of CH, etc. The empirical formula of a compound is determined by converting the number of grams of each element to moles and then finding the lowest whole number ratio to use as a subscript, as shown in sample problem 7.8. Often, the mass percent of each element of a compound is given. The mass percent composition is true for any quantity of the compound. For example, methane, CH4, always has a mass percent composition of 74.9 carbon and 25.1% hydrogen. Thus, if we assume that we have a sample of exactly 100 grams of the compound, we can determine the grams of each element in that 100-gram sample, as shown in sample problem 7.9. Converting decimal numbers to whole numbers. Sometimes the result of dividing by the smallest number of moles gives the decimal instead of a whole number. Decimal values that are very close to whole numbers can be rounded off. For example, 2.04 rounds off to 2 and 6.98 rounds off to 7. However, a decimal that is greater than 0.1 or less than 0.9 should not be rounded off. Instead, we multiply by a small integer until we obtain a whole number. Some multipliers that are typically used as listed in Table 7.4. For 0.2, multiply by 5. For 0.25, multiply by 4. For 0.33, multiply by 3. For 0.5, multiply by 2. For 0.67, multiply by 3. Let us suppose that the numbers of moles we obtain give subscripts of the ratio of C to the 1, H to the 2.33, and O to the 0.99. While 0.99 rounds to 1, we cannot round off 2.33. If we multiply 2.33 by 2, we obtain 4.67, which is still not a whole number. If we multiply 2.33 by 3, the answer is 6.99, which rounds off to 7. To complete the empirical formula, all the other subscripts must also be multiplied by 3.